and relative motion. Is that right? All right, let's look at one more problem. A ball thrown into air lands 40 meters away 2.44 seconds later. Find the direction and magnitude of the initial velocity. Well, we need to find V0, the velocity of projection. What do we know? We know the range of the projectile. It falls 40 meters away from the place it is projected, and the time of flight is 2.44 seconds. So let the velocity be v at an angle theta with the horizontal. We don't know the velocity of projection. We don't know the angle of projection. Alright, so let the velocity of projection be v. Normally we call it v0. Let's call it v this time. And angle of projection is theta. Alright, here is the object. It is projected with the velocity v at an angle theta. There it goes. Okay. Now the horizontal component of the velocity vx0, which is the same as vx, will be v cos theta. Is that right? And the vertical component will be v sine theta. The initial x velocity vx equal to v cos theta. Now, did I really have to call it initial? Well, this is the initial and also the final, because the x velocity will not change. And vx remains a constant. The initial y velocity, yes, we got to say that the initial, because y velocity keep on changing. Vy0 is v sine theta. Well, x equal to vx multiplied by time. The horizontal range is the horizontal velocity multiplied by the time of flight. Now, the horizontal range is 40 meters and the time of flight is 2.44 seconds. So we have 40 equal to v cos theta times 2.44, and that gives us one equation. V cos theta equal to 16.4. V cos theta equal to 40 divided by 2.44, or V cos theta equal to 16.4. Now, Vy0 at the maximum height, what is the vertical velocity when it reaches the maximum height? The vertical velocity will be 0, and what is the time taken to achieve that? Half the time of flight. The time taken for the projectile to reach the maximum height is half the time of flight. If 2.44 is the time of flight, the time taken to reach the maximum height is 1.22 seconds. And at that time, the y velocity will be 0. And what is the expression for the y velocity? The y velocity Vy is Vy0 minus gt. Is that right? So Vy equal to Vy0 minus gt. And this Vy0 is v sine theta. Alright. So we're going to say this Vy will be equal to 0 when this t equal to 1.22 seconds, half the time of flight. So look at the equation we produced. 0 equal to v sine theta minus 9.8 times 1.22. We can now obtain a value for v sine theta. Can you solve for v sine theta from there? Well, I have solved. V sine theta equal to, take this to the other side, 9.88 times 1.22, that is 12. Okay, let me see how much mathematical background you can use to solve this problem. what we are looking for, we need to find the value of V and the value of theta. And we have two equations. V cos theta equal to 16.4. V sin theta equal to 12. Can you find the value of theta from here? If you know your trigonometry, you know that sin theta divided by cos theta is tan theta. So what happens if you divide equation 2 by equation 1? I hope you understand what I'm saying. Divide the left hand side of equation 2 by the left hand side of equation 1, and divide the right hand side by the right hand side of equation 1. So what do we get? We get V sin theta divided by V cos theta. Is that right? V sin theta divided by V cos theta. V and V will go. Sin theta divided by cos theta is tan theta. Now, V sin theta divided by V cos theta is 12 divided by 16.4. So we get tan theta equal to 12 divided by 16.4, and therefore theta equal to tan inverse of this number, that is 36 degrees. You see how beautifully we were able to get that angle theta. And now that you have the angle theta, you can find the value of V. V can be obtained from any of these equations. I used this one. I said V equal to 12 divided by sine theta, 12 divided by sine of 36 degrees, that is 20.4 meter per second. Well, the study of projectiles is an interesting and very fascinating subject, because we see projectiles all around us, and we only talked about some rudimentary, basic, fundamental aspects of it. Alright, I want you to learn these concepts and learn how to solve problems. Okay, and I think we have come to the end of Unit 1, if I'm not mistaken. That means you are now ready for your Test 1. Remember, at the end of each unit, you have a practice test. So look at the practice test, make sure you can do all the questions, and then go and do your test. Okay? I will get back to you with the next lesson later on.